Thank you. So tonight, across all those things, before I go to the next slide, I tend to call this talk undisciplined or being undisciplined. Everyone likes to talk about interdisciplinarity and transdisciplinarity. I keep shooting for just being undisciplined and a bit more experimental approach. It's important to remember, I try to not make this a generic thing, so I think it's kind of focusing around my practice and how that can kind of give some hints as to where you can want to go. I didn't make this card, but it's one, this is I think from Alan de Botton. It still sits behind my desk. And it's one I like. And it's one that will kind of keep coming back around because I do think it's important to talk about practice, what that means, paths to practice, and all those different points. So right now, this is what I do, I guess. As was explained in the intro. But I think in terms of this, what's really important and what I really want to shape in this talk tonight is even though these things start to become like 4 different lines and we can say you have different jobs, to be honest, like for me, it's all the same thing, right? The teaching part is the same as the being a boring administrator running a program, which is running a research lab, which is running a consultant like design practice. There's like, you have to list them on different lines, but they're not really separate. Like they all feed each other. And really what I want to show through some of the work later on is different projects start in different places. Like some projects might start from teaching. Some projects might start from a project that then get turned into a teaching piece. And everything flows back and forth. I mean, I think it's important not to say like, all right, especially in this, like, do you practice or not, right? And I think it's important to kind of think about what that means. For the context of what I'm talking about tonight, when I talk about practice, it's all of this stuff. So the other thing, in terms of giving you a hint of where I'm at the moment. So yeah, I'm the chair of the Digital Futures program at OCAD. And to give you, the only way I can explain what it is, like, so these are my colleagues, right? And I think, what's important for us is, as an interdisciplinary program, because like, one of we always say the gift and the curse of having a program called Digital Futures is nobody has any idea what that means. So the downside is nobody knows what that means, but the upside is you can kind of do whatever you want. Because it's like, oh, you're not digital futuring correctly. Because like, it's not a discipline. Like we don't have a discipline, we don't have a history, so we can kind of make it up. And experiment across these different things. So if you can imagine, this is our core faculty. And like a lot of places, a lot of things revolves around co-teaching. So it's all about kind of mixing these different disciplines on a daily basis. So I decided when thinking about like the title called Paths to Practice, I decided to go and I'd never really thought of it as a path, so I decided to make a graph of like, seriously, like, all right, how did I get here? So this is it. This is me. So the first thing, me starting out having no idea what I wanted to do, then deciding to go to architecture school. Like I'm not one of these people that you always read everyone's applications and they're like, I was born to be in architecture school. I've always wanted to. I had no idea what I wanted to do. So I spent a couple of years at a random university. Then got a bachelor's of architecture at SCAD in Savannah, and then moved to the AA getting my master's. And I'll talk more about going through it, but this is literally everything I've done from starting undergrad till now in terms of positions. And the thing I want to point out is kind of like the previous slide, there's never a moment where it's only one thing. Right? There's never like a single moment like all I'm doing this week is just working with clients or just teaching. And this has become the sort of norm for me of all of these parallel processes that feed each other and give you different opportunities. There's a couple of highlights in this one though that I want to point out. So that is the point in time of undergrad architecture school when you have that moment where you're like, you know what? I'm super into this whole architecture thing. I think it's really amazing. I'm really probably not going to design buildings when I grow up. One, because I start to realize that like I'm a lot better at all the other stuff than when it gets down to designing buildings, and I'm much more interested. So, this was probably second or third year undergrad for me. There was that moment of like, wait a second, I'm fascinated by the field. I'm probably never going to get a license. The other kind of timelines that are important on this for me are these two. So when I switched to, essentially when I left grad school, I was, at that time, still in the mode of, being the person who was, teaching kind of programming classes around like, design tools and like how do we make, scripting stuff and, Maya and all that sort of things. Then worked for Zaha for a couple of years, and then when I left there and started teaching more fulsomely, that's when, I sort of switched into my own practice. And it has led to these two distinct chapters in my sort of teaching practice. So for the first kind of almost 10 years, like anytime I was like teaching in an architecture faculty, I was absolutely like the least architectural person on the entire faculty, right? Like it was like, all right, yes, you go, you take Nick's studio, it's kind of weird, whatever, do the thing. They let him hang around, that sort of thing, right? So I spent almost 10 years in those sorts of things. People were nicer to me than that. But then there was an interesting thing that happened when I joined OCAD in the Digital Futures program, where I immediately went from being like the least architectural person to the most architectural person. And it actually set up a really interesting thing for me. So in that first chunk where you're like the least architectural person, you're constantly looking out to other fields, other technologies, other people being like, how do we bring this stuff into the practice of architecture, right? Like, what does computer science mean? What does material science, whatever. So it was always I'm here in architecture, we need more stuff, bring it in. But then an interesting thing happened when you start in what I've been working on more for the past 6 or 8 years is, when you step into these sort of interdisciplinary worlds where there's a huge thread of new technologies and how new technologies are shaping a lot of fields, you start to realize that instead of bringing stuff to architecture, you bring methods of architecture into those fields. And you start to realize that there's a huge amount of work within architecture that's incredibly beneficial when you start dealing with how new technologies roll out in the world. Whether it's, on these weird devices or materials or machines or whatever you like. Like there's a different flip where you can say like, all right, there's so many practices of how we think about how architecture is put together that really is, it's incredibly important right now. And I still always get the thing of people in the crisis of like, oh my God, architecture's going away. Which, as I was saying, I spent a couple of years not talking to architecture schools, and I was really kind of surprised that people were still really worried about this. Because when you go and you start to flip it around, the skill sets are incredibly important to thinking about how do you integrate people, technology, material, all these sort of stuff, time. Because really, all architecture things are just future exercises. You're like, all right, however many years from now, there will be another object on the planet that will shape the way people move, in and through it. So I could say this is the end of my talk because that's really it. This is my path to practice. But I have more slides, so I'll keep going. So there's a couple of things I also like to remind people. When we think about practice, in whatever form you want, it's so easy to kind of, and I work in a very sort of technology-heavy thing, but I think it's really important to not get caught up in the like, oh, in the future it's going to be so weird, and just remember how weird it is right now. So on one hand, there's this relationship between digital media and physical architecture, and for that, I always like to go back to this moment. Not the future, this is 2014. And the great moment of the NCAA basketball Final Four played at Cowboys Stadium where the screen is bigger than the court, right? You're no longer even going back and forth. Like the experience of everyone there is viewing a smaller version on the court than if they watched it on the screen. And they haven't done it, and this isn't even the biggest one anymore, but like, they could have literally just mapped the basketball court one-to-one on the screen and played it out. But it became this bizarre moment of, there's probably 60, 70,000 people there, physical action, digital action, info, all going through, and it's the question of like, but wait, they still showed up, and why, right? It's still a thing. So this you know, there's sort of these questions that people worry about, like, you know, is there this kind of thing between digital media and architecture? Like, it's over, like it's here. It's like, it's more just a thing of like, learn how to deal with it, because it's, and this was 2014, it would be even weirder now, because you would have, you know, 60,000 smartphones as well, right? Same thing, like that would be much bigger than the screen itself. So on one hand, I think it's important to remember that our baseline of normal, like this isn't a big deal in terms of media. I think the other thing that I like to keep in mind in terms of the built environment is not only is there media, but it also, it's already thinking. So I like to bring.
Coming! Oh, there's cars! Bill, just put me back for me controlling. Oh dear Jesus, I could never. Oh, where's it going? God damn, Bill. Oh my God. Oh, this is so scary. Oh Jesus, this is my first day out and I'm about to die.
Oh, come on, relax.
Oh my God, Bill. I couldn't do it. Oh, is the car coming? Just, oh my God, they're going to hit us. This car.
So hit the brakes, hit the brakes.
But
Right.
Jesus.
Now you're driving.
So again, we're not talking about the future. It's a video from last year, you know? In this moment of like, in our built environment, there are little micro environments we can inhabit that drive themselves. How do you deal with that? Like, how do you think of that? Like, how does it change everything around it? How do you start to think about how we move through the world? Because it isn't a big deal anymore. It's, you know, buy the Tesla and like put down the money for the extra software upgrade, right? You could push a button and be like, okay, my micro architecture now drives itself. So those are the two things that I like to keep in mind, or I kind of lay out there as what I see as the sort of baseline of when you start to talk about the general public. This is our basic reality. For me, that's all well and good, but I get this question from a lot of people. So that's all cool, but like, what do you do exactly? And I like to use this picture from a collaboration from a couple of years ago with IK Studio in Boston. It was their piece for the Seoul Architecture Biennale. And it's always this integration of, you know, materials, high tech, low tech, you know, very robust technologies, very handmade technologies. Whereas, you know, they were building a pavilion for the Seoul Biennale where they invented this whole new like carbon fiber system. And then I talked to them, they're like, hey, but we also need it to have interactive weather. It's like, what? But yeah, that was the brief. They're friends, so it's okay. So then you think about things like, oh wow, that sounds super advanced, but I think what's really important is to not get caught up in just saying like, oh wow, that sounds really fancy. I think, you know, the tools that we have at our disposal, that like mere mortals have at their disposal, you can think through these things and work through it. So like literally, you know, yes, there's some smarts on the software side, but you know, weather and clouds, you know, you spend a couple of weeks learning about the pieces that used for indoor mushroom farming, and they can make these giant clouds, and then you can control them with custom software. But it's always this sort of mix where sometimes very slick, sometimes very messy, but looking at really integrating the two, because my interest is always kind of integrating, you know, the materials, the material intelligence, the digital intelligence, and the actual interaction. My way of working is this. You know, I end up, you know, most all of my work ends up being in collaboration with somebody, and it's usually trying to think a few years down the road and start to prototype some of the potential ways that we might inhabit the built environment. And the way that you do that when dealing especially with technology, like just talking about technology is super boring, like really boring, because there's always a version you can do, right? And in having a version that may not be perfect is still always better, because you have to be able to talk to people about it and have other people experience it. So it's like, you know, sure, we can't actually one-to-one prototype going to the moon to figure out how to go to the moon. And like, yeah, wouldn't it be better if we had this like super anti-gravity chamber? That would be great. Don't have one. What's next? Have a pool. Great. What can we work out in the pool? So at this point, I'm going to show a couple of projects. And these are the sort of things that run, these are some of the themes that I run across in different ways all these projects. There's a couple of things that I like that I'll go through what these actually mean. First of all, for me, not to mix up, collaboration doesn't just mean optimization. In that, collaboration doesn't mean I got a really good structural engineer and they made it look really good, right? There's other moments in design practice where, looking at how you collaborate with people to invent kind of weirder solutions. Material amplifiers is, again, going back to this idea of how do you start to create these new hybrids of, physical space, physical material, digital sensing, chemical sensing, and really start to put those together. Failure gradients is something that's kind of it's an interesting design feature. When you start dealing with interactive work, that's going to live for a little while. Like, there's nothing worse than saying like, oh, it's an interactive thing that doesn't work, right? It's like, oh yeah, I promise it worked yesterday. But I like to think about the actual design challenge of making it where it's never a yes it works, no it doesn't, and how do you make the gradient of how well it works. Sediment are all the drawings that you end up making, because when you deal with sensing, it's all invisible. Like, how do you start to make those visualizations around these actions of like, look, it's sensing. Well, how? Because it's all invisible. Adventures in babysitting. We'll come back to this. When you start making installation pieces, you leave and someone has to take care of it. So there becomes these interesting groups of people that inhabit these spaces where it's not only the general public, but you're also having the people like, who do you train on how to operate this thing? That become the sort of like super user because you can't do it all the time. And experimental plumbing is, for me, you'll see a lot. There's an incredibly large amount of a mixture of, sort of robust, very high tech, not high tech, but sort of advanced pieces of hardware and software, and almost like craft, low fidelity pieces that I make by hand. So there's always a mixture of the two. So we're going to look through a couple of projects. This one, we'll start here. This is the urban algae folly that I worked on with Ecologic Studio in 2015. So for the in Milan, for Milan, and essentially everyone loves a good bioreactor project. Everybody needs algae in their life. So with this one, though, we didn't just go with like, hey, look, it's algae, they make oxygen, everyone loves that. It's like a tree. It was a little bit of that, but like we started to think a couple of steps forward and look at this relationship in a pavilion format of what do the algae need versus what do the people visiting the algae need, and kind of learning how to play out in software almost a sort of fight or balancing act between the needs of the algae and the needs of the people, which all kind of bases itself around shade. The actual, the simplicity of it is, what we're doing is there's several different circuits of algae and pumps that flow through these custom ETFE panels. So like, normally with ETFE, you inflate them with air. But we work with the manufacturer to kind of crease them a little bit. So they're like, well, if they're airtight, they're probably watertight. So we started running the algae through the ETFE. And obviously, if you're in Milan in the middle of the summer, the other thing we're dealing with is shading, right? So we're kind of controlling the algae, the different algae concentrations in the panel to provide different gradients of shading for the people underneath. And then also balancing that out with, the algae do also need certain amounts of exposure to the sun for their reaction, but then they get too hot, so it becomes a little ecosystem. The other thing that's happening is, this is it was a really simple like Internet of Things project. So, all this stuff's being monitored, calculated in real time, so you could always be looking at how much oxygen was being created, how much CO2 was being lost, how that worked out to things like trees. But this was the kind of web version of, it was at Expo, so like 20 million people go to Expo, but there's also the version where you can just see online of what's actually happening, what's the interaction, all in sort of real time. Getting back to figuring these things out, Still for me, I make a lot of drawings because it's really the only way to work these things out. This is the system. So on one hand, to be honest, at the end of the day, the only controls I have is I can turn valves on and off, right? Let algae flow through or not, or turn on a little thing that's a mister that cools them off. That's it. But to do that, we're running through a different set of things. So we're monitoring the movement of people and their locations underneath the pavilion, how many, where are they, how they're moving around. Also testing, kind of keeping track of the health of the algae by, measuring their pH and the temperature and all those things. So there's like a bit of formula running in the background that let all these things happen. Those are the components. So it's three circuits. Each circuit has 3 different valves, so 9 valves in total, and then 9 position sensors in total. And that's it, right? And this is the part too, where I always kind of like the moment where you can get really excited about the electronics, but if you look at this, it's a really kind of boring system, and it requires the architecture to bring it to life. Actually, this on its own, I have other things where it's just you can hold it like in a suitcase, and it's not a project, right? It's just valves clicking, and it starts to have this moment of, electronics are great at sensing, but you need the material to actually have anything happen. You need the algae, you need the structure, you need all these, you need the ETFE systems. Just saying wow, it's responsive doesn't really mean anything. That's just the control unit. So that, when thinking about how it actually works, so the pavilion itself, we've got the ETFE panels with the algae running through. Then there's the whole underneath part that holds the algae tanks and the electronics. Then set up are a series of just distance sensors that we can kind of triangulate where people are, not exactly, which is a point we're going to come back to in the last projects I'm going to show, because one of the things that as soon as you start doing anything that's interactive with people, what you really want is man, I really just want to know where everybody is in the room. That's not very easy to do. So we couldn't figure it out in this case. So in this case, it's 9 distance sensors giving us pretty much another thing. So that's the system. The other thing that happens in all these projects, especially at this sort of scale and these sort of budget, they come together really fast. It's not oh, we built this thing, tested it, worked out all the bugs, brought it on site in Milan. It's no, I was in Toronto, they were in London, sort of figure it out, show up 2 or 3 days beforehand, try and make it work. But the problem is you still have to work on the project. You just can't say I hope it happens. So you start to, in almost all these projects, invent little design tools. So for us, one of those, this idea of, okay, we're going to run a bunch of algae through these pleated ETFE panels, and we know all we can do is just control the speed of a valve opening or not. What do we do? Right? There's not Google, what are the correct timings of these sorts of things. So you start to invent these simple little tools, and is a 2D representation of this thing perfect? No. But at least lets us, when we're on a Skype call between the two places, we can talk about it. You can start to talk about wait, what are the sort of gradients we want to talk about? What is it, is it about pooling them in different ones? And you have to have, even at the simple level, tools that let you describe the different things happening. So these, again, start to become some of the components. The truthful side story. These are the distance sensors that get mounted to the structure. Something went, there was, in the wide world of getting the public involved, fun things happen. Does anybody have a guess what went horribly wrong the first time? The algae were okay, no. So here's the thing. When you make a thing that says, ooh, it's interactive, and then you put these things on there, everybody thinks it's a button. Right? They mangled them. It had to be fixed a ton of times, right? Because it's there, And we were like, okay, we want to be able to get people at sort of waist height. We'll get the best readings from them that way. But it also means like, oh yes, of course, this says interactive. And then it would be like person trying to push it like a button. I mean, like, why isn't this working? Get annoyed with us. So we had to then like actually move them around. But, you know, and not because of the software, not because of anything, because of the physicality of it, right? Because there's no moment where it just becomes digital, right? Even the sort of sensing mechanisms are physical objects. In this case, you know, it required these specific ones because it had to live outdoors and these are the only one that exists, that sort of thing. And, you know, valves, controller, that sort of thing. And this is the moment, you know, I always tell everyone like the super glamorous life of doing these sorts of pieces is you like live in a hole for 5 days, like with sit in a hole with a laptop and with like algae on everything you own to get it together. And that's sort of where it got to in the end. So the next project I want to talk about is a completely different, you know, in this sort of case, like Ecologic and I, this is the second algae project. We did like our first algae project, I guess in like 2005. So this would be our second one, and we've collaborated on different things for a while. You'll see another one we're working on both then and now. The next one is a really different situation. So we ended up working with Marina Abramovich on her prototypical experience that started in Toronto and then moved. It's traveled around. So Marina, as probably many of you know, fairly, you know, pretty world-renowned performance artist. She got to this moment of thinking about, you know, instead of me being the performer as a performance artist, like, can I create these series of structures and exercises and other things for people so that the crowd becomes the performer rather than a sort of spectator. So this happened, and, you know, she worked with some other architects and designers designing this, like, you know, connected structures that people would go through wearing these, like, you know, very specific outfits.
Exercise number 1.
Right? So you're wearing headphones.
Arms. Place your hands together with your finger interlocked.
Right? We'll keep going. There's a problem though, right? So you make it where the public comes in, they're doing the performance, there's all these chambers that are completely enclosed, but then no one sees it, right? Which is a small problem, like when it's like the tree falling in the woods problem. You have these groups of people move through all of these chambers, doing these exercises that she's designed, but you still sort of want to see it and see what's happening. So what happened was, like, it then became the question of how do we, you know, in the simple ways, oh, well, we'll just stream it online. Won't that be easy? And then there was actually a place set up in Pearson Airport where you could watch this, which was really bizarre. The idea of, like, what, you know, you just go to, like, gate B to see, like, performance art. So, you know, no matter what, like, it's like, okay, well, we need to first thing is, like, we just need cameras. So for us, and in talking to her, she was like, you know, we need cameras, but I don't really want it to look just like security footage. So we switched to GoPros, so it was a kind of different look. So you start to see these things as people are moving through. But then there was something else, right? So it was like, it wasn't enough to be like, well, we'll just stick a camera in every room, no problem. The thing that happens pretty quickly when you put a camera in every room is you essentially end up with a television station, right? 7 cameras set up that you need to switch between is a television station. And beyond that, it wasn't just that we needed to build a television station, we needed to build a television station that could run itself. So there wasn't going to be someone sitting there at the controls. It was going to be, hey, we want to follow this one group through as they move through this over an hour. Let's do that. So for us, it then became a secondary layer of using ultra-high frequency RFID. So essentially, like the same sort of things you see in shops, making sure you don't steal stuff, embedding them in the doors to let us know when these people are running through. So in this case, you know, the brief at the end of the day was like, you know, build a self-running RFID television station in the middle of a park, which is, you know, a thing in itself. So on one hand, again, it gets back to the same moment of, running a lot of cabling and a different sort of, this, for me, you start getting into like, even with electronics, it's quite easy when it's like, all right, everything's like 2 meters away, 10 meters away. But then when you start running like 50 meters of cable, everything changes and it becomes much more, well, it becomes more like an architecture project. And, again, for us, when you start getting these weird briefs, you start to think about how to actually make it happen. So, in this case, it's, again, changed now, but, ultra-high frequency RFID readers are, either used for very specific purposes, like they were used for like tracking packages in a warehouse or that sort of thing. So it's like, how do I get it to talk to a TV camera? So there's this moment of, really expensive electronics tied to really inexpensive electronics, which tie it back to something else. So like there becomes this moment of, getting the different pieces to talk to each other is always a kind of little chain of events. And sometimes, it's super robust things. Sometimes you're just building little connectors and hand soldering and hand designing circuits. And it always takes a little bit of both. The thing that made it work, going back to everybody had to wear costumes, is you could just hide the RFID tags. This is on the outside, but we could just hide the RFID tags in the boots. So in the same way, it would be like, the alarm would go off in the store. In this case, it would be like, all right, you've moved to this room, switch the camera, which is all kind of going back and forth. Again, that's part of the test setup. Super reverent. If you've never done anything with electronics, no matter what, it always involves stuffing in a box and like pretending that it works really well. Like different levels, but like there's a reason everything is encased in something, because it gets ugly in there. The other side of this too, which was interesting, was like, people sometimes ask me, wait, how did you end up doing this stuff? And like the other honest answer is like one project at a time. Because like you get to where like someone asks you like, oh, do you think that you could do like a interactive multi-camera setup? And I'm like, yeah, absolutely. And it's like, have you ever done that before? It's like, no, definitely not. And I think like that's the moment. But you start to learn a little something every time. So when you start to do like 7 or 8 cameras, you literally start having to use the same switcher hardware that they have in a television studio. And then you learn the world of, how do you get to go from really expensive switcher to really cheap GoPro, which is like a whole other piece in between. And then how do you then link it back to an RFID tag? So this was our sort of hardware setup, which there was also obviously horror stories with that. But like this actually becomes the system diagram for us, right? And what it means is, you have 6 of them. Yeah, 6 GoPros that have to go to a different switcher because you can't run HDMI cable for that far. So they have to go to an SDI thing, which then goes back, to the switcher, which then is all plugged into a MacBook. And the MacBook is literally just talking to one Arduino, which is talking to a bunch of other ones that are talking to RFID readers. And then at the end of the day, it's honestly a processing sketch talking to Arduino and the sketching program and the kind of switcher program all at the same time that makes it all work. And it works, like totally works. But this is the thing of like, how do you make it happen? Because there's little pieces that make sense, and there's always like, air gaps of like, wait a second, there's nothing here. We have to kind of invent, sometimes it's like in making a little piece of hardware. Like sometimes it's literally building a cable that you spend like a day building custom cables by hand so that you can make different things talk to each other. Because you never really have to figure it all out in one. It's always about whether software, hardware, or whatever, how do you chain things together and make them talk to each other. So again, that's the basic setup. This is the other part I wanted to come to. This is where on my hashtags at the beginning, adventures in babysitting. So, the first dry run in Toronto, we were sort of around, hovering. If it's not working, we can kick it through. But then like the next time, it was going to Basel in Switzerland, where it was going to run for 3 months. And it's like, okay, this is a different thing. I'm obviously not just going to I can't live in Basel for 3 months and make sure the software is running correctly. So you go, you install it, and then like you have to start to think through. It's not only designing around the people who are visiting and how do you think about their interactions, but there's this amazing sort of hidden super user group in the world that are basically museum docents, right? The people who have to turn all this stuff on, turn it off, make sure it's working, and back and forth. So you then have to build a sort of interface system that would make sense to a random person who has no idea about any of these things. So this was what a lot of the interface looked like. And to be honest, I ended up basing it off of just like carnival rides, right? Like, okay, put somebody on the roller coaster, hit go, and there you go. And then there's the other things of like, oh crap, if you notice that it's not right, the camera needs to be on like a different part of the chamber. Just click on the chamber and it moves it along. So it becomes like, you can spend a lot of time worrying about like, is it this perfect thing? Is it working perfectly? And you do all that, but it's not gonna work perfectly. But part of the design is also thinking back, like how do the people who sort of work there, how can they interface with this system? Because they don't want to think about everything that's happening. Like, how much control do you give them? So this was that moment. Like, I was literally there for like 48 hours. Go, install it, meet these like 4 people who are gonna run it, and be like, here you go, kids. Here's your manual. Let's run through it. Have training day. And then say, good luck. But it works, right? I mean, like, there's little things along the way, but like, there's this interesting moment where, as soon as you start to embed pieces into any space, I mean, it's why people have IT departments. But what happens when that becomes embedded in other things that don't have, manuals per se? So this is the sort of view of it. It was outside the Tangley Museum in Basel for like 3 months. So switching gears, that was, the stuff with Marina, that's super client driven. The stuff with Ecologic is much more kind of collaborative, generative, that sort of thing. Like the thing with Marina was like, it was like got connected to her and it was like, oh crap, we need to figure this out. It wasn't like, that one's not a collaboration. That one is I think that you're stupid enough to take this project on, so we're asking. This one goes back to the other side though. This one flips all the way back over to playing out a research project that I had been thinking about for a while and having an opportunity, so then playing it out. So this is a piece I built for the Shenzhen Biennale in 2016, not the last one, but the one before that. And it's the bi-city, so it's Shenzhen and Hong Kong. And really what I was interested in doing is, having worked a lot with interactive pieces, I've always kind of been interested in visualizing behavior and kind of bringing together both material notifiers along with digital. And also just like being fascinated with like the moment you tell people that something is interactive, everyone like wants to wave their hands, right? Like, wait, is it working? Am I interacting right? So what I really wanted to do was to build a piece that you really didn't have a choice. You stood there and it interacted with you, right? Your job is just to stand there and be slightly confused with what's going on, and that's perfect. And to see like, there's a little bit of interaction, but really it's about it interacts with you instead of you trying to make it respond. So this is the factory. Like, it was interesting because like this was an old flower factory in Shenzhen. Being Shenzhen, it was like, it's like old flower factory across the street from like the Bentley dealership, which is really funny. But they were building the place even as we were trying to install things. So this is kind of what it looked like. This one has a... So really what's happening is it's a really slow refresh rate screen made out of these like little shaking fields of wire wheat almost. So what happens is like it pans around and measures where people are in the room, and as the LiDAR scans past, it kind of creates this sort of standing wave of motion in the metal rods. and wherever you are in relation to it, it kind of stops the motion in there. So think like, the sort of like rock in the stream moment. So like if you're standing there, like those don't move. So you're basically stopping the movement rather than causing the movement. And again, this was just one kind of investigating a few things I was interested in. One, really just having a piece where I wanted people to stand there. Two, like looking at this moment of like what's the relationship between just visualizing visualizing data through material, and in this case, this kind of seemingly very floppy, it's incredibly controlled, but it's, how do you get this like really floppy motion from, using a servo with a certain thickness of like metal. And to be honest, the real secret here that makes it all work, that we came to after like a month, is industrial Velcro, right? So the reason why these things can, why all of the pieces have the nice little wobble to them, industrial Velcro. We went through a lot of things. Side story. To make industrial Velcro work in an old flower factory that they're literally constructing while you're there means that you spend like 6 hours of your life with like cleaning fluid scrubbing the floor of a flower factory, right? Because if you can imagine, you have to stick something down to the concrete. So you just like scrub, 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 and it almost looks like a pit crew. Like one person will be like, all right, clean it, dry it, stick it down. So again, the sort of glamour part, because there was like a constant layer of dust in the air in the place. So again, this one was about honestly playing out some of these effects that I'm interested in, and thinking about different ways that people can interact with the space, where really all it's doing is taking a constant history of the people who visit. Because the other thing that happens in this piece is, over time, the places where people are more likely to stand, it starts to build up an inertia in the system. So it becomes harder to make some of the strands wobble if they're very popular. So they kind of build up this inertia over time. So again, this is a thing where that's great. How do you design that, right? How do you actually work on it? And so this comes back to another piece that we use a lot. So this is just a piece done in Unity. Game engines are wonderful. I've never actually made a game before, but game engines are the best, which I'll come back to in a minute. Because for us, it lets us kind of think through. You can do a bit of the digital sim on the wobble, but also like fake, some of the wiring and like the interaction. You can walk around it and at least start to test some of the ideas of what's happening as, visualize the actual LiDAR pan and see what's happening. So, for us, this was as important as anything, because you need a design tool to talk about along the way. That's sort of describing how it works. So there's this sort of field around it. And you can't see my cursor, that's okay. So as it pans through, it activates the line it aligns with, and you sort of stop the motion of the ones you go with. I'll keep it rolling. I always show these things too, because in some ways, this is the project, right? It's like 350 servos. That's all. That is the bucket of 350 servos, but it doesn't really matter. There's so many. We can all get really easily caught up in, making the electronics and making things move around, but, you need the other pieces to do anything. That's the other guts of it. The other thing that's important, because of the way it plays through, is it's all the first time I started messing with LiDAR. The previous piece was just using normal ultrasonic distance sensors, which I'd use for kind of lots and lots of time. Obviously, the biggest difference is ultrasonic stuff, it's like a flashlight in the room, right? So you get a sort of beam where it's like, no matter what, I hit something in this beam. But essentially with a LiDAR, it's a laser pointer, right? Literally a laser pointer. Where, you can get a different fine-grained piece of interaction if it's like, okay, it's a beam that's 2 millimeters wide, going back and forth. We'll come back to LiDAR. I actually did a series of prints of, on the opening night, just leaving a camera filming everyone, watching themselves being like, what is this thing? This woman liked this project more than anyone else I've ever made. She came back 3 times. I have a video. But So I'll quickly get through the last project I want to talk about. There's a part 1 and a part 2. So this is back to Ecologic. This is an older project that we built. It was the first time that the FRAC in Orléans had commissioned an interactive piece for their collection. And, we went about, again, kind of looking at how can we take the most benign dead materials and bring them to life, and both electronic and physical. So it's a sound piece. So it's, polypropylene, metal, and Piezo Buzzers. This is the overall sort of effect you get. So the biggest thing here is this is still the only project I've ever done where the only behavior that you perceived was audio, like nothing visual whatsoever. Like it was only based on what was happening. So I'll keep moving because the appropriate response to that is like, that's great, Nick. It's making noises. And this is where I get back to, when you start to work, this one really pushed the moment of when you're designing a piece that's only dealing with sound, it's an incredibly spatial problem between the pieces and all these things, but at the end of the day, what you're getting is little things honking at you. And you're like, how do you actually think through on how to design these things? Is it working? Is it not working? So again, this was a part London, part Toronto piece. Ecologic doing most of the work on the physical structure, me doing most of the work of the actuators, but then obviously it's all happening in parallel and in collaboration. So you see, that was an interesting one because it's all built in-house. All the bent tubes, they basically built a pipe bending machine and their own sort of notation system to be able to make the structure. They essentially just used part of the project budget to buy a new laser cutter that cut all the polypropylene and engraved everything, so it was kind of a complete in-house piece. On my side with the Piezo Buzzers, to remind you what the sort of raw material is ooh, that's painful, yeah. Anyway, think of this horrible beeping in a coffee pot, right? They're incredibly cheap, incredibly awful, and what we started to go with usually with the code, you just send a tone through them or really cheap, bad toys, that sort of thing. But when you actually look at the physicality of them, it's actually a physical movement that happens from the electrical charge. So we went with can we manipulate them both through custom software and through pieces of hardware? So on my side, instead of sending a tone, it's just literally turning them on and off really quickly, which makes it where you can make them sound like crickets instead of just beeping. The other cool thing that we realized is literally with different lengths of plastic tubing, that's where you start to build in different tonality. So there's stuff that no matter what I did in software was never as good as what we could get out of software plus a little bit of cheap plastic tubing, right? And then it was all right, bit of plastic tubing. And then you could keep manipulating that way. So it got more advanced than that. But again, it's kind of a really simple hybrid that we went through, but it's an important one where it's all right, some of it's solved through software, some of it's solved through, we didn't just stumble, that was the 50th choice of plastic tube. The other thing we were dealing with a lot in this is, with something at the end of the day, it was 500 Piezo Buzzers, all happening at once while you're interacting. How do you tune the behavior? How do you think through how to, you can't just go let it run. So we started looking a lot more of building out these wireless interfaces to the software in the background so you could literally be interacting with the final work and adjusting its properties as we did it. This thing that looks like someone ran over it, this is literally why the project happened. So we built the simplest version of it, and we had clones of them. One was in my studio wall, taped to the wall in Toronto, and one was taped to theirs in London. And we could just I could talk to them on Skype, send them new code, upload to theirs, back and forth. And literally, this is only 12 buzzers with LEDs attached to them so we could see a little bit better. But again, Would have been nice to build the whole thing, but that's not how it worked. But this is the design tool that literally meant that the final piece worked. Because you always have to have some sort of currency. Like, even if it seems too simple, it's like, wait, that's what it was? But it works. You can at least have all the conversations about behavior and how to make it change. This is another one that it became an interesting relationship between, this is my version of like the sort of building information model. Obviously because all of the panels are modeled in 3D and then unrolled, the other thing was like we had to understand the locations where all the buzzers were embedded to write the software. So there was this secondary sort of like digital model in the background that embedded the buzzers, and each of those colors was the different tones. Because really what wants to happen is, as it goes through, all these buzzers are sort of spread around. There's a bunch of like A, B, C, D tones. And what happens as people move around is you're sort of like scattering them with motion. If there's no movement around it, it gets incredibly loud because it's like, there becomes no delay in all the A's, so like 25 of those buzzers go off at exactly the same time. As you introduce more of a delay into the system, it'll be like da, 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 and then B, and then like they scatter, and then like it's always this sort of relationship where the object itself wants to bring itself back into sync, but the people moving around it are moving it out of sync. So it becomes this little bit of push and pull. And again, like these sort of, to be honest, these sort of drawings are also the things that I made so I could understand what was happening. It was as much afterward as, because really all we're doing is take it, build the model, because the only way the software works is if every one of those buzzers knows exactly where they are in space and how far away they are in centimeters from everyone else. So then we use the digital model and just like wrote a really simple export script to convert it into, arrays of triples so that they know where they are without hand coding it. Same thing, the other part is working on it. Again, it's a Unity project, so finding ways to simulate parts of it, of like the delay that comes in, where you can also visualize it. And again, it's not a tool that's replicating what's happening because it actually gives me more information. Like it's a little rougher, but I can also see it. It's like, oh wait, these delays aren't working correctly because I can actually visualize it. So it's not a simulation. It's a pure design tool that otherwise we had no idea what we were doing. And really at the end of the day, it became we were on site with this secondary interface where walk around for like a day, change it, update it as we're moving around, and it's the only kind of reason why it got there. But it became it's like this total integration where like, the wiring is part of the structure, is part of the polypropylene, part of everything. Which leads me to the last thing I'll talk about, which is we got version 2. Version 2 is currently in the works. How about that? This project was done a few years ago, and I was very happy because it managed to travel to several different sites around Europe and be disassembled, put back together, and actually work again. But then like a random person in Barcelona decided to tackle it or fall into it or something. And it brought up to us like, not only just fixing it, but what are the things when you come back to a project a few years later, like what's the new version of this? Like, what are we missing? What if we could just sort of flash it like a software update, like going back, like same thing you can do with your car now, right? Like, oh, wait, just flash the software, think about what it might do. And as things have moved on, we were like, all right, the two different pieces are, one, a much more robust way of tracking the movement of people, and two, making it where having a much more advanced sort of learning system for the buzzers as they go around. So this becomes the two sort of parallel things. So they've been thinking about, these simple moments of, wait, what if we could more accurately track people in the round, because if you remember, it's an object, almost like a sculpture you're moving around. Like, how can we think through, developing new, much more intricate patterns of controlling the buzzers and what they want to do? So in one case, it's like, okay, if we take it as a given, we can do it. These are the sort of patterns, so they're sort of on it with the patterns. On the right, I came back to the world of like always looking for new sensors. And for the past sort of 6 months, I've been really interested in cheap LiDAR, right? Because every time you see sort of self-driving cars or whatever, like LiDAR is part of it, because essentially what they're doing is generating a point cloud. So the same thing we were talking about with the single LiDAR. We'll come to it. Like, it's laser pointer, but just spin it, right? And if you spin it fast enough, you essentially generate a point cloud, or normally a 2D point cloud. With the more expensive ones, more 3D point cloud. These things used to be obscenely expensive. Now they're really not. So I decided to start with the cheapest, literally the cheapest one you can buy, and start to play with it. Right, so all you're doing, it's the same idea as the previous sensor I showed, but just spin that thing, right? Spin it. And the basic data you start to get from it is this sort of thing, right? So you get a point cloud. So you can start to see, what you're sensing is not to do with just like distance numbers. It's like, all right, you're sensing spaces. You're sensing actually what's happening. And you're literally doing it with a $100 sensor, which is great. But then as soon as this happens, I'm used to dealing with 6 inputs, but this gives you 300 inputs all at once, which is sounds great until you start to try to code for it. So for me, it also kicked off another bit of experimentation of how do you actually start to deal with this sort of data, which kicks me into the Nick's first round with machine learning. And in this case, I call it machine prototyping because nothing is that fancy. And I love this moment of super advanced robot. And if you see any sort of little device that's kind of learning its position, it uses LiDAR. But my method is always to kind of go with what I know, and mostly what I know how to do is I do totally get drawings. And if I've got a piece that's making points, obviously, all right, first thing to do is, if I know it's making points, what if I just start to connect those points so that, no matter what, I can start to think about the interaction within a space or what's happening within a space as a series of drawings, right? So basically turn it into a drawing machine by simply connect the dots, right? Very simple first thing. As soon as you do that, that's where actually the first round of machine learning stuff comes in, because as soon as you start doing that, you realize you know what, the sort of easiest low-level stuff in machine learning looks really similar, right? Which is just simple doodle classifiers, right? So this is the same thing of when the Google put out of everybody draw an ant, right? So for them, you can generate 5,000, 10,000 ants, these images that are classified immediately. But what I'm wanting to do is all right, that's really great that I have a room that I want to have these drawings about, but I don't have those image sets. Because and this is where the whole thing around it's kind of interesting, because everyone likes to talk about machine learning, but the design process has nothing to do with learning. It has to do with teaching, right? You teach the things, and generally you teach them with a ton of images. So the problem became wait a second, how do you start to think about how to generate these custom image sets to teach a sensor for a specific place to understand what's happening? So my guess was to generate them. So I started out this really simple way of, this is just back in Unity, so in the game engine of if you know anything about how video games work, ray casting is how, you let people know all right, I shoot a little light beam out, whatever it hits, I know its name and how far it's with. It's it's a really normal game mechanic. But that's basically the same thing as LiDAR. So I built a little raycaster and started to say, like, with this really simple thing, can I make it where I use the raycasting functionality to draw the same way I was drawing from the LiDAR? And so what you're seeing up on the right corner in the tiny little square is it's spinning with this kind of simple simulated humanoid block moving around, making those drawings. And this is the first version. It was really slow, but you're literally just making a JPEG. And what's cool is, like, since you're doing it in a game engine, you can know where the object is, so you can self-classify the images. Because, like, we don't want to have to do it by hand to say, like, all right, this drawing means X. And the reason why they're fuzzy, honestly, is like because the cheap LiDAR is noisy. And then the noise is totally just in the code, right? Like, if I turned it off, like, the raycasting would be perfect, but I don't need perfect drawings. I need, like, noisy drawings. So this got a little bit better. I then got a little smarter on how to do it, where instead of spinning it, it was just like do an array of them at the same time, and then start to move it around. So it became this little simulation running in the background where I'm generating like 10 or 15,000 images to be like, all right, this is what it would be like if a person, this image essentially means a person is standing in the room at this sort of position. And you don't do one, like you leave it there for a second, so you generate like a few hundred per position to teach it. And then you start testing it like the next one around of like, all right, I've built it, I've built the neural net model where then on the left, instead of it being completely output, what you're seeing here is the game is generating the drawing of what's happening, feeding that drawing to the classifier, and then the thing on the bottom is trying to guess the position. So these are sort of separate pieces of software. Like this is Unity. There's a Python thing in the background, but this is a separate piece running from the neural net to actually guess it. And then the final piece of this is, can I then take the series of drawings that were generated from a complete simulation, and then feed them back to the real LiDAR to know? And the answer is yeah. It's a little, it's still very version 1-y. But yeah, so the idea is, again, looking at this moment of digital models and digital space in a different way, where, it's just a drawing machine. It's essentially a digital simulation to make a drawing machine to feed to a physical sensor that, uses a neural net. This has moved on a little bit, so there's a few other versions of this, and really my interest in this going forward is this is also a sort of modular piece. So right now it's a line of sight problem. The same sort of thing in the next pieces we're going. You can scatter 5 or 10 of them in the room and actually start to get back to this moment of actually tracking movement of people, several people, because obviously this was one of the first total proof of concepts. But it kind of gets back to really what you want if you're dealing with interactive works is like, I really just want to know where everybody is. But the interesting thing for me is, it is the piece that, if you work on like hardware and coding forever, and then you start to think about teaching, like it is just a teaching practice, right? Like how do I teach the system? Because like part of it's coding, but literally it's how do you design the images? How do you design the information to feed it? And all the sort of machine learning stuff is both scary and interesting, only because like the good news is like the tools are unbelievably approachable now. So it means that much more interesting and weird people can be using them for things. Forever it could only kind of be used for evil, but now the tools are actually interesting enough that like normal people can do it. Which is back to where we are now. So like, we're still kind of in the moment. I can't show some of the latest stuff on that one yet, but it's moved on to kind of multi-person tracking and that sort of thing. But we're back to this moment of like being able to think about, learning and what's the interaction mobility, because the other thing I can tell you is for the second version of the Folly that we're building, it's less about just responding to humans and kind of seeing if we can herd people in certain ways based on noise patterns. So instead of it just being like, okay, I'm going to go over here and activate a behavior, like we're doing it as a test to see like, all right, I'm going to make this pattern of sound. What do the people do? and then kind of learn from that, and then run. So it's basically running a ton of experiments on us over and over again, but harmless. Anyway. That's it for me. So I think I'll mute that one. So really, that's, if I come back to something, the whole moment of, there's a few different things to do. One, architecture does take you in a lot of different places. I still just did an architecture degree. I've never, in terms of coding, I've never actually taken a course in it before. But it's not that big of a deal. And I think it's really important as we get back to, one of my biggest interests has been less about designing computational tools for the creation of architecture. And I'm much more interested in, the actual testing of the new types of spaces that we can create. So how do these things filter into new behaviors and new materials, new interactions? And I think it's all interesting because it's the same stuff. And architecture can play a huge role in all of these things. So that's it for me. Thanks.